Hello, welcome to this video. So this problem, will be a structured question. That actually is the last. As you can see, the last structured question. In conventional part on paper 1. And then that would be about percentages. Of course. Will be related to sequences and series. So for part A, the amounts of investment, or about investment of a firm in the first year is $4 million, and then the amounts of investment in each successive year. That means every following year will be R% less than the previous year. That means the percentage decay. The percentage decay will be constant. That will be R%. Each year decreased by R% of the previous year. So the amount of investment in the fourth year, would be 1 million something. So find out. So of course, in part A, we need to make use of 4 million. And then we need to make use of R% less than, so that's why 1 minus R%. As for the power, so from the first year to the second year, we need 1 year. And then from the first year to the fourth year, so the number of years in between, so there will be 3 years. And there will be 1,048,576. So to solve this polynomial equation, so we need to divide both sides by 4 million, and then we will get 0.262144. And then we try to take the cube roots. Try to take the cube roots on both sides of the equation. Now take the cube roots. Or you may try to use your calculator Shift X cube. On the right hand top corner. Of the calculator, and then you can find 1 minus R%. Maybe to the power of 1, so that will be equals to 0.64. And then R% will be 0.36. And then R%, that means R over 100. So that's why we try to multiply both sides by 100. So R equals 36. And that will be the final answer for part A. Part B. So in the previous part, that will be about investment. This time, so you can see it will be about revenue, about income. The revenue made by the firm in the first year. The first year is 2 million. And then the revenue made in each successive year, or again, as you can see the works here. Each successive year. That means every following year will be 20% less than the previous year. So find the list number of years needed for the total. Wow, very important word. The total revenue made by the firm to exceed 9 million. Before we try to set up the inequality, so first of all, maybe we try to let n be the number of years for the revenue, for the total revenue to exceed 9 million dollar. So as for the total number, the total revenue, so for the first revenue, so that would be 2 million. and then the revenue for the second year. So that would be 2 million times 1 minus 20%. And the next year, 2 million again. So square. And then we have many years. And then for the nth year, okay, for the nth year, so that would be 1 minus 20% and minus 1. Okay, and then the total need to be exceed 9 million. Okay, now, so first of all, okay, in the next step, okay, I want to simplify the inequality. So by canceling all the zeros on both sides of the inequality, so I try to divide both sides by 1 million. And then on the other hand, I try to rewrite 1 minus 20% into 2.8. So, and then the inequality will become 2 plus 2 times 0.8 plus 2 times 0.8 squared, and then plus dot 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 up to 2 times 0.8 to the power of n minus 1, bigger than 9. Okay, so and then the left hand side of the inequality, okay, will become a GS with first term 2 and common ratio 0.8. So of course, okay, I will try to make use of the geometric series, okay, the sum of the first n terms of the geometric sequence, okay, that will be the Sn formula, a times 1 minus r to the power of n, where n is the number of terms, and then here, okay, we have exactly n terms, okay, for this series, over 1 minus r, bigger than 9. Okay, so and then we try to make 0.8 to the power of n to be the subject. Okay, so how? First of all, maybe 2 over 0.2, it will become 10, and then we try to divide both sides by 10, and then in that case 1 minus 0.8 to the power of n, okay, would be bigger than 0.9, and then 0.8 m would be less than 0.1. Okay, so and then of course, okay, I will try to take logarithm on both sides of the inequality and then pull down the power n using the logarithm property. Next, very important, okay, you can make use of your calculator, okay, to try to evaluate the numerical answer of log 0.8. Well, that would be negative, am I correct? So if you try to divide both sides by log 0.8, so n will be bigger than log 0.1 over log 0.8. Okay, so n, okay, will be bigger than 10.3188, the phone digit number, right? 3188 5115. Okay. So that's why here, okay, so the least number of years needed, okay, will be 11. Okay, so let's conclude. Okay, so the least number of years needed will be 11. Okay, and this part is finished. B2. So will the total revenue, so first of all, okay, we are considering the total revenue. Okay, so just now, okay, the total revenue needs at least, okay, 11 years, okay, to exceed 9 million. So now, okay, will the total revenue made by the firm exceed 10 million as well? Okay, so here, okay, we are looking at the highest possible total revenue. So of course, okay, we'll be looking at 2 million plus 2 million times 0.8, and then that's 2 million times 0.8 squared, and then plus dot dot dot. Right? So that would be the infinite sum, okay, or you may say the sum to infinity. And then, okay, we'll make use of the sum to infinity formula. There will be a over 1 minus r. And then the sum to infinity will be exactly equals to 10 million. Okay, so bear in mind, okay, the sum to infinity is an upper limit which cannot be achieved, okay, in the reality. So that's why, okay, so you may conclude, oh, the total revenue, okay, will less than 10 million. So the total revenue will not exceed $10 million. And then this part is done. Finally, B3. So the manager of the firm claims that the total revenue made by the firm, will exceed, okay, the total amount of investment. Oh, that would be a very important question to ask. Okay, so a company cannot keep investing without making profit, without making revenue. Okay, so that's why here, okay, so about the amount of investment, okay, so that would be what was R? R was the value of R in part A of 36. Okay, so 36. Okay, so of course, okay, to justify the claim, okay, we need to or in a certain year the total revenue will exceed the total amount of investment. And so of course, okay, we'll try to consider the total revenue. Oh, that would be 2 million, the first term, plus times 0.8, maybe in the nth year, so that would be to the power of n minus 1 will be bigger than the investment, okay, 4 million, and then plus 4 million times 0.64, right, 0.64 plus dot dot dot. If we can solve, okay, if we can solve the n satisfying this inequality, then the claim is agreed. Otherwise, okay, the claim will be disagreed. Okay, so that will be the general direction. Okay, so for the left hand side and the right hand side, so it seems that, okay, that would belong to two different GS. Okay, the left hand side of the inequality, so that would be, well, we have done that before. Okay, so we just try to use, okay, the fraction. So A times 1 minus 0.8 to the power of n over 1 minus 0.8. And then for the right hand side is similar. First term is 4 million. Okay, and then 1 minus 0.64 to the power of n over 1 minus 0.64. Okay, so and then we may try to cancel all the zeros on both sides of an inequality. So and then we'll get 1 minus 0.8n bigger than 10 over 9 times 1 minus 0.64 to the power of n. And now observe that's the two exponential terms. Okay, so here we should look at these two terms. So observe that the base 0.64. Wow, what a coincidence. 0.64 equals to 0.8 squared. Wow, what a coincidence. Well, actually, it's quite artificial. Okay, so that's why here. Okay, so we will try to, maybe we can rewrite a bit. So that would be 1 minus 0.8 squared and then to the power of n. Okay, so and then of course, okay, with this kind of insight, this inequality is actually quadratic inequality. So that's why, okay, we try to put everything to the left-hand side, right-hand side equals 0. So that would be 10 times 0.8 to the power of n squared, and then minus minus 9 times 0.8 to the power of n minus 1 bigger than 0. And now we can factorize a little bit. So you can see 0.8 to the power of n will less than negative 0.1. Well, that would be rejected because the nth power of a positive number will never be negative. Okay, but on the other hand, 0.8 to the power of n will be bigger than 1. Okay, so for what value of n will lead to 0.8 to the power of n bigger than 1? Now, this is the quadratic inequality, right? So, quadratic inequality, still remember? Okay, either the left-hand side or the right-hand side, because, okay, we want positive. Okay, so using similar technique, okay, we'll try to take logarithm on both sides. Okay, so that would be n log 0.8 bigger than log 1. And then n, okay, would be less than 0. Whoa, so weird. So weird. Okay, so because n has to be positive. N has to be positive. Okay, so, well, that's why here n bigger than or equals at least bigger than 1. Okay, so that's why no solution. Okay, so there's no solution here. So there's no solutions here. So of course, okay, at the end, we may conclude the claim is disagreed. And then the problem is done. Thank you for watching.